What if the brightest streak in tonight's sky isn't a comet, but a probe checking our address? Right now, a 73 trillion pound object is slicing along the ecliptic at 124,000 miles per hour, and it isn't from here. A ghostly tail is starting to form, for reasons no one can pin down. Its scattered light shows extreme negative polarization, a signature never seen in any comet. Its path sits within 5 degrees of Earth's orbital plane, and it slipped past Mars with timing so precise the odds are below 1 in a million. Harvard astrophysicist Avi Loeb estimates a 30–40% chance this isn't entirely natural. Then, just as it neared Mars, several NASA feeds went dark during the government shutdown. Here's the unnerving part. 3I Atlas approached from a sector where extraterrestrial observers could watch Earth transit the Sun. Any civilization within a 10-degree cone around our ecliptic would find us using the same transit trick we use to spot exoplanets. With a 5-degree inclination, 3I Atlas is right in that discovery lane. If someone sent it after flagging Earth, they've possibly been watching for millennia, waiting for the perfect window to arrive.
For months, people have asked the same haunting questions about 3I/Atlas. The answers are more unsettling than you'd think. This interstellar visitor shows 7 distinct anomalies that defy complete explanation. Unlike cigar-shaped Oumuamua or the more conventional 2I/Borisov, it refuses easy labels. Start with the most disquieting feature: its implausible mass. At over 73 trillion pounds, 3I/Atlas outweighs SpaceX's Starship by a factor of roughly 6 million.
That estimate comes from Harvard analysts who noticed something odd. Despite visible outgassing and an expanding shroud, its course barely budges. Usually, jets of vapor kick comets around like a leaking balloon. Not this one. It's so massive, those thrusts hardly register. Stranger still, given what we know about the density of interstellar rubble, there shouldn't be enough solid material drifting between stars to deliver something this heavy into the inner system. Loeb calculated that, based on known mass distributions, we should have encountered hundreds of smaller bodies before meeting a behemoth like this. We didn't.
As he put it, there isn't enough rocky matter in interstellar space to ferry such a giant rock into the inner solar system over the past decade. Timing complicates things further. On October 3, 2025, 3I/Atlas passed within 18 million miles of Mars, close enough for rovers and orbiters to image it in detail. Perseverance recorded a slanted streak crawling across the Martian sky that didn't match normal star trails. And the kicker? As this historic flyby unfolded, multiple NASA sites and data pipelines went quiet due to the shutdown. Awfully convenient timing, just when the world needed live updates. What we captured beforehand only deepens the puzzle. The body looks elongated, more Oumuamua than a rounded comet. It lacks the dramatic tail we'd expect from such activity. Instead, it sits inside a diffuse ionized coma that doesn't behave like anything in our catalogs.
Chemistry adds to the riddle. Spectra show cyanide and carbon monoxide, common in comets, but also signs that the environment around 3I Atlas resembles Mars-like conditions rather than a classic comet-forming region. That hints it might hail from a planetary crust, not the deep freeze reservoirs where comets are born. Its solar behavior is bizarre too. On September 25, a coronal mass ejection, a solar storm, hit 3I Atlas head-on. Scientists expected the particle blast to stir dramatic changes, maybe even shatter it. Follow-ups on September 27 and October 2 showed no fireworks, no breakup, no sudden tail, just a steady swelling of its envelope. It's as if the object is tougher than any natural comet ought to be. The real sleep stealer is polarization. Sunlight scattering off comet dust produces characteristic patterns. Every comet we've measured shows positive polarization at large phase angles.
3i Atlas shows negative polarization of about -2.77% at a phase angle near 6.4 degrees, more extreme than any comet on record. That implies dust with fundamentally different properties, rougher, more jagged, or composed of materials unfamiliar to our system. Its trajectory tells its own tale. Unlike random debris, 3i Atlas runs almost perfectly within the solar system's plane, the same flat disk where planets orbit. The chance alignment probability is roughly 0.002%, or 1 in 50,000. Add the close pass by Mars, a projected near-Jupiter flyby on March 16, 2026, and arrivals timed to encounter multiple worlds, and the combined odds fall below 1 in a million. From an engineering standpoint, if you wanted to survey several planets efficiently, you'd hug the ecliptic and time your arc to maximize encounters. That's precisely the path 3i Atlas follows. It will sweep within about 33.5 million miles of Jupiter, close enough for high-resolution observations if instruments are on board. As Loeb notes, if an intelligence plotted this route, a 5-degree tilt makes sense. It's near optimal for watching main belt asteroid transits, which span roughly 10 degrees above and below the ecliptic. Some researchers go further. Dr. Susanna Fennier proposes that objects like 3i Atlas might be planetary seeds. Her simulations suggest massive interstellar bodies plunging into young systems could jumpstart planet formation, letting worlds assemble rapidly around ready-made cores instead of taking millions of years to grow from dust. If so, a slice of Jupiter's mass might trace back to an ancient interstellar visitor. Speed is another flag. Now racing at about 37 kilometers per second relative to Mars, 3i Atlas will ramp to roughly 42 kilometers per second near perihelion, around 150,000 miles per hour, fast enough to lap Earth in 10 minutes. That velocity isn't unusual for interstellar objects, but in tandem with its mass, it means stupendous kinetic energy. If it were artificial, the engineering implied would exceed human capability by orders of magnitude. Size estimates have swelled as data improved. Early looks suggested a few hundred feet across. Now the nucleus appears closer to 3 miles wide. 3 miles of solid body, not counting the gas halo. For scale, that's larger than the impactor that ended the dinosaurs. Picture a small mountain barreling through space at a pace that crosses the US in under 2 minutes. Europe's spacecraft may be our best shot at answers. While NASA dimmed, ESA's Mars Express and the ExoMars Trace Gas Orbiter kept watching. The JUICE mission is slated to intercept 3i Atlas in November 2025, though downlink lags mean delayed results. Those datasets could finally reveal unusual surface textures or interior structure. What truly chills isn't any single oddity, it's the pattern. Every metric strains what nature should allow. Mass too high, chemistry too odd, timing too neat, trajectory too exact. Scientists call this a black swan event, so unlikely it forces a reset of assumptions. Loeb puts it plainly. Anyone claiming 3i Atlas is purely natural must account for all 7 anomalies with natural mechanisms. So far, no one has. The object glows in ways typical comets don't. Some predict a dramatic fade or fragmentation near late October perihelion. Others suspect it may defy expectations and hold together. The most unsettling scenario is what Loeb dubs a Trojan horse, technology disguised as nature. The perfect camouflage would resemble a comet, but not quite. Just off enough for careful observers to notice, yet similar enough to evade immediate suspicion. Think through the implications. If an advanced culture wanted to study planetary systems, what better tactic than probes that mimic natural objects? They could drift between stars for eons, occasionally threading systems like ours. A 5-degree inclination would aid multi-planet encounters. Unusual resilience to solar storms would fit advanced materials. We're not declaring 3i Atlas artificial. Whether 3i Atlas is natural or not, it proves these visitors can be far more massive, intricate, and baffling than we imagined. The next one could be stranger still. If this encounter taught us anything, it's that we must be ready. Enjoyed the video? Give it a like. It really helps the channel. Subscribe and turn on the bell so you don't miss new episodes. Drop your theory about what 3i Atlas really is in the comments, and share this video with friends. More space stories ahead.